Okay, this is section 2.5, Reasoning in Algebra and Geometry. So our goal today is to be able to connect reasoning in algebra and geometry. So to accomplish this, we're going to use a few properties of equality. We've all talked about these properties before. So the addition property says that if A is equal to B, then if we add another number, say 2, A plus 2 is equal to B plus 2 if A and B are the same. The subtraction property. If we subtract the same number from both A and B, then we're still going to have the same, they're still going to be equivalent. The multiplication property. If A is equal to B and we multiply A by a number and we multiply B by the same number, then they're still going to be equivalent. The same with the division property. If A and B are equal and we divide A by a number and we divide B by the same number, they're still going to be equivalent. The number may be different in all of these instances, but they're still going to be equal to each other. So the reflexive property, it's like looking in the mirror. So A is equal to A. The symmetric property, if A is equal to B, then B is equal to A. So the order that you put them does not matter. And the transitive property. This should look familiar because this is very similar to the law of syllogism. So if A is equal to B and B is equal to C, then A is equal to C. The substitution property, which we're going to use a lot, we can replace, if A is equal to B, then we can replace any value that has A in it for B. But we're going to be using this quite a lot. So now let's go to the distributive property. So they break it down into two different parts, but they're both just the distributive property. So if you've got A outside of the parentheses, when you distribute it, you say A times B plus A times C. And then in the difference, A times B minus A times C. So you just distribute the A. Okay, so now we're going to justify our steps when solving an equation. Okay, so they want me to determine what's the value of x, and they want us to justify each step. So I know that angle AOM and angle MOC are supplementary. So the reason I'm going to give is angles that form a linear pair are supplementary. Okay, so, and I used abbreviations, so I used the angle symbol. Angles that form a linear pair are supplementary. Now we're ready to write our next step. So the next thing we're going to do is we're going to say, okay, the measure of angle AOM plus the measure of angle MOC is equal to 180 degrees. And the reason we're going to give for that is basically the definition of supplementary angles. So now our next step is we're going to plug in the values. So for angle AOM, I have 2x plus 30. And then for angle MOC, I have x. And we know that when we add those two angles up, the sum is going to be 180 degrees. Now what I did was I substituted in my pieces of the equation for my letters, basically. So this is going to be the substitution property. Okay, so now my next step, I'm going to combine my like terms. So I end up with 3x plus 30 is equal to 180. And what did I do? I combined my like terms. So this next step, I'm going to put 3x is equal to 150. Now how did I get there? I use the subtraction property of equality. Now I'm solving for x, so I have x is equal to 50. Now how did I get that? I used the division property of equality. Now notice that up here, I did do some adding, but I didn't do it to both sides. So that's why this step was combine like terms and not the addition property of equality. So when you do those like addition property of equality, subtraction property of equality, multiplication property of equality, you'll do it on both sides of the equal sign, not just one. Okay, so now we have some properties of congruence, and I'll have a sheet for you to print out, or I've probably already given you one in class. So briefly, the reflective property of congruence is basically looking in the mirror. AB equals AB, or AB is congruent to AB. The symmetric property, the order that you state them doesn't matter. You can say segment AB is congruent to segment CD, just as well as you can say segment CD is congruent to segment AB. And the transitive property. So once again, that's similar to the law of syllogism. So segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then we know that segment AB is congruent to segment EF. So let's try another problem. So when you're doing these, we want to know what property they use to go from here to this next step. So what did they do? They subtracted 9 from both sides, right? So this would be the subtraction property of equality. Now let's take a look at B. Angle O is congruent to angle W, and angle W is congruent to angle L. Angle O is congruent to angle L. So that is going to be my transitive property of congruence. Okay, now let's take a look at C. Measure of angle E is equal to the measure of angle T. And then they have the measure of angle T is equal to the measure of angle E. So they just said the same thing in a different order. So that's going to be the symmetric property of equality. So now let's write down what the definition of a proof is. So a proof is a convincing argument that uses deductive reasoning. So a convincing argument that uses deductive reasoning. So this is the general format of a proof. Sometimes they will give you a figure to look at, sometimes they will not. They will always give you a given statement. So in this case, they say the measure of angle 1 is equal to the measure of angle 3. And then I can see here that they have also marked it in the figure. And then they tell you what they want you to prove. So they want us to prove that the measure of angle AEC is equal to the measure of DEB. So your first statement is always, well, it's almost always going to be your given statement. And the reason is given. So you need to figure out a roadmap on how you're going to get there. So you don't want to leave to go to the restaurant until you know what restaurant you're going to. So you want to know where you need to make the turns. And I may go one way and you may go a different way. But as long as we follow the same principles, we're still going to end up at the same place. And your last statement is what you want to prove. So let's take a look. Okay, so they want us to write a 2-column proof given the measure of angle 1 is equal to the measure of angle 3. And they marked it over here in our diagram. They want us to prove that the measure of angle AEC is equal to the measure of DEB. So I'm going to look to see where I'm going. So one of the things I notice is this is really, angle AEC is really just angle 1 plus angle 2. And now I'm going to look at DEB, and I'm like, oh, this is really just angle 3 plus angle 2. I'm definitely going to be able to get there. So my first statement is going to be that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. And why can I say that? Well, I have angle 1 and angle 3. I know they're equal to each other, and I'm adding the measure of angle 2 to both of those. So I'm adding the same thing. So that is going to be my addition property of equality. So I want to look at where I'm trying to get. So I'm trying to get to something that looks like the measure of angle AEC. Oh, I've got that. So I can put that the measure of angle 1 plus the measure of angle 2, and I'm just going to write it in this different format, is equal to the measure of angle AEC. And still part of number 3, I'm going to write the measure of angle 3 plus the measure of angle 2 is equal to the measure of angle DEB. So the reason I'm going to get for this this one happens to be on your sheet, is the angle addition postulate. So now I have what I need, because they tell me right here that the measure of angle 3 plus the measure of angle 2, oh, those are equal. And I know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle AEC. So I can write that the measure of angle AEC is equal to the measure of angle DEB, and the property I used to do that was the substitution property. And that's it. We have proven what we set out to prove.